Okay, before we jump into tolerances of location, what I'd like to do here is have a review of the test. Normally, when everybody's in the classroom, I can kind of talk about the nature of the test and the overall results. So I'll do that a little bit. It's a little bit more difficult since I can't talk to each one of you individually, but overall the test was very good. I know you may have looked at your scores and thought, you know, that wasn't as good as I wanted it to be, but typically this first test is not the best test, it's the worst. And it's because you're being introduced to a bunch of new concepts and you have to think about aspects of features that it's unlikely that you've thought about in that way ever. So all in all, I would say the average was very good. Typically test number 2 is better and the final is even better yet. So don't fret if the scores seemed a little low. And of course this session you're going to have the option to take a pass or fail. I'm going to put on the Canvas here in the next day or so an official, I guess a ballot or an election form that you can determine whether you want the letter grade that you're going to get in the class or whether you just take the pass-fail. And again, I encourage you to go to the website and look at the policies and procedures about the pass-fail. There's a pass with a A through C and a pass with a D, and a few other options there that I want you to be aware of. And again, I'll have that form there soon. You'll have to make an election, otherwise I think the default will be a pass-fail. And again, I don't think it has any impact on your grade point average. It isn't prejudicial when you go to a four-year school. This was a statewide decision and everybody recognizes that these are very unique circumstances. Okay, so test number 1. Test number 1 is really to get you thinking in terms of geometry and, you know, real mathematical geometry, not just a generalized concept of it, where we talk about geometric lines, points, and planes, and we use those as benchmarks or ways we evaluate certain characteristics of parts. So again, the terminology is a little new, the way of thinking about it is a little new, and then you've got the whole symbology thing that you've got to get through. All right, so I always start out with this type of question here, question number 1, which is regular coordinate dimensioning results in a square or rectangular tolerance zone. Why is that a problem? Okay, this is a question that a lot of people miss, and I understand why, and I want to make sure that this concept that this question brings up is very clear to you, because it's very easy to confuse the tolerance zone with the actual feature. Now, I always make an example of a feature with a block with a hole in it. Okay, so you got a number of features here. You got the block and you've got the hole and all the other surfaces, the edges, all those are features. But when we talk about the tolerance zone, we always have to make sure that we're clear that we're not talking about the feature. So in my example, we had a location dimension, let's say 1 inch from each edge, and a tolerance of plus or minus 5 on each one of these. I don't know if that was the actual example, but this is an example. And I said, and this is the part that I think it's forgotten, is what we're talking about now, what we are locating here is a feature that you probably don't even realize is a feature. We are locating the derived median element of this hole. We are locating the center line of this hole. That line does not exist in physical space. It is a location in space, actually in air. You can't put your finger on it, it doesn't physically exist. And for the purposes of evaluating the tolerance zone, it doesn't matter what this feature is. That can be a round hole, it can be a square hole, it can be a triangular hole. When we talk about the tolerance zone, we don't care about the surface of that hole or the shape of the hole or anything. We are only concerned about the center of it, the derived median element of it. So I always try to emphasize that when I start drawing tolerance zones, I'm looking right down here at this center line. I'm really zoomed in quite a bit. And so we can forget about all of this, all the actual physical features, and we draw up that center line. Now again, this is really zoomed up. So I have this located 1 inch this way, plus or minus 5. Now the edges of that block are way the hell down here. They're not on the board. We are zoomed way, way in. Same way here. And this is way over here. So we are looking right at the center line, really zoomed in big time. And we have a plus or minus 5 tolerance zone. Well, that plus or minus 5 bilateral tolerance yields us a tolerance zone. And that tolerance zone is minus 5 this way, plus 5 this way, plus 5 this way, and minus 5 this way. So the tolerance zone in this example is a square. It is a 10 thousandths by 10 thousandths square. It is locating the center of a round feature. So the tolerance zone is actually square, and that's the problem. That's why a square rectangular tolerance zone is a problem, and we talked about why, because with the tolerance zone defined like this, any center that fits within that square is going to be an acceptable location. So the actual center could be here, it could be here, it could be here. And we said that the distance from here to here is 5 thousandths. That was the designer's intent, that no feature, no center line would be more than 5 thousandths away from that edge. Here it's just, right on the edge. It's getting scary, but it's still acceptable. This one, on the other hand, is from this center line more than 5 thousandths. We know that that's a triangle. If this is 5 thousandths and this is 5 thousandths, we don't have to do any math. We know that this hypotenuse is more than 5 thousandths. So this is greater than 5 thousandths. And that's the problem. The problem is the conventional way of dimensioning and tolerancing with the plus or minuses and the unilaterals and bilaterals yields this square or sharp-cornered tolerance zone. It could be rectangular, it could be square, and it allows a feature to be acceptable and still be more than 5 thousandths in either direction from that center line. That is an undesirable result, and the only option we have then is to tighten up the tolerance zone so that we guarantee that the no feature would be more than 5 thousandths away, and we do that by making that a smaller tolerance zone so that the distance from here to here to that new corner is 5 thousandths. Well, then that means that this location is less than 5 thousandths. That's a bad thing too. That means that now, well, with the big tolerance zone, we were going to accept the bad part. Now, if a feature lies right here, it's still less than 5 thousandths away, but it's rejected because it's outside the tolerance zone. So you're damned if you do, damned if you don't. You either accept bad parts or you reject good parts. Not a good system. Okay, so that's the problem with the square rectangular tolerance zone is, in a word, the tolerance zone isn't uniform. The only uniform tolerance zone would be a circle that sort of clips off those corners, and no matter where you go in that tolerance zone, as long as you're within that circle, you will be no more than 5 thousandths away. So that's the problem and the answer to question number 1. What I have learned is that doing these tests online, it's a lot harder to do the essay questions, so I'm going to try to focus on multiple choices. I'm sure that'll make you happy. It's definitely a little bit easier to grade too, so going forward here, there won't be too many of these where you have to write an essay. But as I've said, your best understanding of this is your ability to express in words these concepts. So if nothing else, if you practice saying it, you'll understand it a little better. Okay, question number 2. Certain geometric concepts are fundamental to understanding GD&T. Points, lines, and planes are the building blocks for defining and controlling parts and their features. Define the following. A point is a unique location in space with 0 dimensions. It has no width, height, or depth, or weight, or color, or odor, or any of those things. It is a non-existent location, and it is unique. If there are 2 points, they have to have some distance between them, and therefore it is not a unique location. But we can take that individual point, create another point, and the straight line distance between them then becomes another geometric entity, which is a line. So from one point to another point, the distance between them is a geometric line. And I said it's, truth be told, it's really a line segment because a true geometric line continues out forever. But no matter how closely you space those 2 lines, there's some space between them. And in that space, you can put another point and another point and another point. So there is an infinity of points on any line. And all we're really identifying are the 2 end points of the line segment. Okay, so that's the second geometric entity. That line then has 1 dimension of length. So we're starting out with a geometric point. No dimensions, a line, 1 dimension, and then of course the next logical thing is something with 2 dimensions, and that is a geometric plane. And if we take 3 non-collinear points, we can always establish a plane between them. So a plane is what we use to define flatness. A line is what we use to define straightness. The geometric plane has no thickness, therefore it is perfectly flat. But it does have length and it does have width. So that's question number 2. List 1 of the geometric controls for each of the following groups. I wanted the name of the symbol, or if you could draw it somehow. So for form we have straightness, flatness. I guess I'll draw them here. Straightness, flatness, circularity, and cylindricity are our form controls, and I just asked for 1. Profile, we have profile of a line, profile of a surface. Orientation, we have angularity, perpendicularity, and parallelism. And position, we have concentricity, coaxiality, and angular, and true position, or just position. Actually, the true position is what everybody calls it. It's really just a position symbol. And we said that, I'm sorry, this is symmetry. Symmetry, concentricity, and position. Okay, and as we said all along here, symmetry and concentricity are special cases of position. Perpendicularity and parallelism are special cases of angularity. So more and more you'll see this used and less of this. Likewise here, you'll see angularity used a little bit more. So those are our symbols. I do want you to know those. I do want you to know what group they belong in. I think that's important and not that hard to master. All right, question number 4, geometric dimensioning and tolerancing is useful because it is written as a single standard. That's kind of useful, but that's not really all that useful. I mean, whether it's one standard or 10, it is a standard. Because I said so, I wish that was, I wish I had that much clout, but no, that isn't why it's useful. There's no other way to control geometric relationships. That's not true at all. There's probably a number of ways to do it, but none of them are anywhere near as compact or standardized and accepted around the world as GD&T. The real reason is because it allows the tolerance zone to be uniform and easily changed in size. It is useful because we have complete control of the tolerance zone. Well, before, with the old way, with the square tolerance zone, we could tinker with it a little bit, but we still had problems with it. We didn't have all the tools that we needed, or all the tools that GD&T has, to adjust and define and refine the tolerance zone. So question number 4 is D. It allows the tolerance zone to be uniform, and we can easily change it, its size, its shape, its position, its extent. We can do whatever we want to the tolerance zone. Question number 5. Material condition refers to the amount of material in a feature. It has nothing to do with what it looks like, feels like, any of that. It is how much material. So maximum material means it is the most material. So if it's a shaft, it is the largest diameter shaft. If it is a part with a hole in it, if the feature is a hole, the maximum material condition is the smallest hole. In order to enlarge the hole, we have to remove material. So that is going towards least material condition. So question number 5 is D. If there is no material modifier in a feature control frame, the tolerance zone is regardless of feature size. Okay, now if you see this or this, that means you are going to modify the tolerance zone in some way under some circumstances. If you do not see one of these or more of these in the feature control frame, you used to see this. That S. Now they've gotten rid of that. That S stands for regardless of feature size. And it means that no matter what material condition you're in, maximum, least material, or in between, the tolerance zone is the tolerance zone. There's no changing it. So it is regardless of feature size. D. Question 7. GD&T allows you to control the tolerance zone size, the geometric relationships of features to datums, tolerance zone shape, all of the above. It is all of the above. D. A lot of D's in there. I'll have to see if that's a pattern. Question number 8. Form controls are intrinsic. That means not that they do not have any tolerance. They do have a tolerance. That's what the form control is meant to do, is establish a tolerance of form. They compare one feature to the other? No, not at all. They do just the opposite. We mean that we are going to evaluate that feature without regard to anything else. They are never evaluated in comparison with other features. That's what it means. So intrinsic means it's within. So if you're an intrinsically good person, you're a good person no matter what. No matter what's happening around you, no matter who you deal with, you're intrinsically good. Well, intrinsic controls means that they are not compared to anything else. And that means practically that there is never a datum. if we have any of the form controls in the feature control frame, you'll never see a datum block. So all form controls are going to be just those two boxes. Okay, number 9, GD&T is defined in which standard? It's ASME Y14.5. The earlier versions of the standard were ANSI, AISI, but it's now been handed over to ASME, and it is Y14.5. The Y14 series is a series of many technical standards, and this one defines dimensioning and tolerancing. Question number 10. The straightness control above controls what? And it controls since it is touching the surface of this shaft, it is controlling the derived median elements of that shaft. And there are an infinity of derived median, or I'm sorry, it is controlling the surface elements, B, of that shaft. So there is an infinity of surface elements. Each one of them is a line on this shaft. And we know that it is the surface elements because the feature control frame is pointing to and touching that surface. Question 11, which is the dimension of location? I know you guys probably don't have the test open. It's not easy to print, as it turns out. So I'll kind of sketch these up very briefly. We have a 6-inch dimension here, a 12-inch dimension here, and we have a diameter 6 inches here. Which is the dimension of location? This is a dimension of size of the block. This is a dimension of the size of the hole. So the dimension of location is the 6 plus or minus 10. So that is the dimension, and there's actually two of them, of course, same dimensions here. Those two 6-inch dimensions are dimensions of location. They are locating the derived median element of that hole. Question number 12, which is the dimension of size? Is it 12? Is it 6? Is it both A and B, or is it neither A and B? Well, it's 12. That is the size of this block. If you had had a diameter 6, that would have been the size of the hole, but you don't. That's not one of your options. So it can't be both A and B, and it can't be neither A and B, so it is B, 6. I'm sorry, A, 12. All right, what is the shape of the tolerance zone locating this hole? Okay, so we have 6 inches plus or minus 10, and 6 inches plus or minus 10. So that tolerance zone is a square box. It's 20 thousandths this way and 20 thousandths this way. So it is a square box of 20 thousandths by 20 thousandths. What is the size of the tolerance zone? Its dimensions in the previous question. It is, oh gosh, looks like everybody gets a free question here. I don't have the right answer. It should be 20 by 20. It is actually it's plus or minus 10, so it's 20 by 20. So everybody will get that extra 4 points. I don't have the right answer there. Irrespective of whether you picked 10 by 10, that would have been the closest one, but it is actually 20 by 20 square. what is the size of the hole, of the 6-inch diameter hole at the least material condition? Okay, this diameter 6 hole is plus or minus 5. Okay, so the way we evaluate this is we convert this bilateral form into limit form. 6 inches plus 5, 5 inches 995, and it's a hole, so it's a female feature. So the hole at least material condition is when the hole is at its largest. So this is least material condition, and this is maximum material condition for question number 5. So for question 15, this, and question 16, what is the hole at maximum material condition? It is 5-inch 995. Okay, question number 17. A feature located anywhere within the tolerance zone is acceptable. That is true. That means that if that tolerance zone is defined, however it is, in this case it's a plus or minus some value, it's a square tolerance zone, we know there's a problem with that, but once that tolerance zone is there, any feature located within that tolerance zone is acceptable. So true is for question 17. Question 18, locations X and Y are the same distance from the ideal location. We have our same old square tolerance zone. And if we have a location X and a location Y, we already know that they are not the same location or same distance from the ideal location. This is closer to this than this one. So that one is false. Question number 19. If location Z is the same distance as Y, so let's say there's location Z, and if we measure here and here, that's the same distance. This location Y is acceptable because it's within the tolerance zone. And Z is just as far away as Y now, but it's outside the tolerance zone. So is that part acceptable? It is not. So no is the correct answer. It's outside the tolerance zone, same distance as Y. So here we've got a case where we have to accept that one, we have to reject that one. They're exactly the same distance from the true position, but we're getting an inconsistency. So again, it just highlights how uneven the results are with a rectangular or square tolerance zone.